All right. There. All right, here we go. So we're trying to wrap up 4.6 writing equations today. And we'll do a little, throw in some applications, some word problems, and see if we can figure out some equations for those situations also. All right. So last time, we left with this problem. Maybe you've still got that somewhere in your notes. And you were trying to do that one basically on your own, follow the procedure. I guess I gave you this point, right? And if we still can see 3x plus 1, y equals 3x plus 1 was the equation. To start with, we wanted a line parallel to that equation, to that line, and it goes through this point, all right? So for either the situation where you're trying to come up with a parallel line or a perpendicular line to a given line, you need to have a slope to work with. And situation, right, for parallel lines is that parallel lines will have the same slope. And that's what you're going to use that given line for, is to figure out what slope to use. So I guess I got that far before I just hands off, kind of tried to wait last time. So there's that slope value in the original line that you're trying to be parallel to. So you're going to use this slope. Writing equations, we always eventually need a slope value and a point to work with. So here's the point that I told you to make that line go through. We have these two different techniques I was trying to present sort of side by side here. I've got smudged slope. Yeah, well, anyway, intercept, slope intercept form, and this other one called point slope form. Use whichever one you want. And I'll see if I can work it through both ways, I suppose. So now the other point is you figured out the slope you're going to use, and don't try to do anything with that original equation anymore. You're making a brand new line equation. So if I use the mx plus b solve for b technique, I'm going to plug in these values for the x and the y in that form, and then the slope that I have. So here's my y is 3 times the 4, and that allows us to solve for the y-intercept b. That's really unknown in that expression or that equation, right? Subtract that 12, and so negative 10 was the p or the y-intercept value for that situation. Always have to go back now. You've got your slope and the intercept, and write the equation in that final form. Okay. A lot of time, in some years, I would just teach this method because I think it's not too complicated or less messy maybe than the other method. But I've seen students see this one in the text, or maybe a Khan Academy or something like that. This is the one that's more traditionally presented. So I'm trying to do them both this year, side by side. So let's do this one. This mold or form still needs a slope value, and your given point are the x1 and y1 values in that form there. So there we go again. Still, we have that same information. Plug in the point value, I go. So always minus whatever number you have. If it happens to be a negative, we might just write minus minus as a plus. But here's the 2. And there's that slope value, and x minus the 4. So you have all the pieces there, and now you just have to rearrange it to end up in that slope-intercept form. Here we didn't know the piece, we solved for the piece. Anyway, here I go. Distribute over there, right? Whoops. Distribute, Steve, come on. And 3 times both of those minus 12, right? That's the x. And this time I have to add the 2 to get the y alone. And ta-da, good. They're the same. All right, same. You should get the same equation, whichever version you choose. All right, so there's that process. Find the slope to use, work with the point that you have, and then you can choose whichever technique you prefer to get to that final equation shape. All right, so I'm gonna, that's okay. Gonna do the next one will be very similar, but let's do it as a perpendicular problem, okay? And so I erase this one. And let's see, I think maybe I did something like this real quickly at the end last time or something like that. And let's work on one that's perpendicular, squeeze it in, perpendicular to this line going through that point. I'll let you get started and go for a while, all right? Same sort of process. You need to figure out what slope you are going to use. Remember that relationship. What's the connection between the original slope and the slope of a perpendicular line? And then once you've got that slope, you're going to work with that point, just like I did a minute ago. If you remember that relationship, or if you don't remember, let's put it that way, right? Negative reciprocal or opposite sign reciprocal, two different switches from the original slope. So come up with your slope to use and then go through your process there. And if anybody's really stuck, you can say, okay, I don't get it. No, I'll help you. Tried to make that point of, we use one or the other of these two techniques where we have this kind of situation where we have a slope at some point other than the y-intercept a lot. So we have to get pretty good at one of these two techniques. So without doing too much, right? I want to make sure you're on the right track. The slope. I'm going to show you the slope. All right. Opposite sign from the positive 2 means it's going to be negative and the reciprocal of 2. 2 over 1, flip it over, and you get 1/2. So there's the slope you should have come up with. All right. Now, let you keep going. Dude. Once you've got the pieces, right? Hopefully that next step is clear. You're just going to plug those pieces in, substitute them in to whichever form you're using. Plug in the numbers. And then it's carefully simplifying, rearranging. So I'm just going to do a substitution, right? I'm just going to do that.
In the beginning of the problem, did you give us m equals 1/2? Or were we supposed to just deduce that m equaled 1/2?
Notice it's negative. No, that is something you need to understand about the perpendicular relationship. The relationship between those two slopes is the negative relationship.
Yes, so I understand that the next problem should have the same slope to make the two lines perpendicular. I'm asking if in the original problem that you provided to us, if you provided us the y equals 2x plus 5, the point of 6, and -3, and the m equals negative.
Right, no, I wouldn't tell you the slope. I wouldn't. You'd be given the equation and you'd be given those points, and it'd be up to you to know and understand.
Okay, that's what I was asking, is if this question provided the slope or not. Thank you.
No, that's why I waited a while. I was hoping you'd come up with the slope while, as the first step, because you've got to figure out the slope. And then eventually I wrote the slope down, hoping you were 2 minutes ahead of me and that was enough time to figure out that slope. Similarly here, just trying to catch up to you. If you had the slope and you had the point, I just wrote down the substitution. I really haven't done any of the work yet. Uh-oh, that's kind of funny. I just made up this point. Interesting y-intercept I'm seeing, I think. What's he talking about? I don't know.
We need you to go over the problem.
Oh yeah, I'll go over it. You ready?
All right. Yeah, whenever you are.
All right, lost somebody. Okay, so this one. So I have my values, right? There's the point values and the slope I figured out I need to use. So here's the calculation. -1/2 times 6, -3. Oh, well, no, this isn't some weird thing like contradiction or something. If I add the 3 to both sides, this is just telling me, oh, my y-intercept is 0. Just by coincidence, I made up this problem, and that happens to be the y-intercept. All right. So
I'm confused because I feel like we're skipping steps. I'm trying to find how you got the slope of the first equation that you put up there. Yeah.
That was given. Okay, maybe I misunderstood your question before.
Okay, so you did provide to us that slope in this problem.
This was provided, and that I want it perpendicular.
Okay, so again, I would love to know how you found the slope of that original problem.
This one?
Yes.
I was just saying, here is a line. All right, here is a line. Write the equation of a line that's perpendicular to it. It's just something you're told an equation to work from to start with. It's not related to anything else. Here's the equation of a line. And so you're given this equation of a line. And another point, 2x plus 5, this is some line that's out here. And here's another point. So you have to be told what's the equation of the line that you're going to compare this new one to. You're told a line equation. So that this is part of the problem. This is the start of the problem. You're given this information, and this is what you want to do with it. Write the equation of a line perpendicular to it.
Okay, I understand that that's the end goal, but again, how are you getting the slope of the line? I mean, that's not being made clear to me.
Oh, this is understanding what the slope-intercept form tells you. M, there's the slope. That's the slope of that line.
Yes, so how are you getting -1/2?
Okay, that was the point I was trying to make. This is about 2 lessons ago. Perpendicular lines are negative reciprocals. Of each other. Okay? 2 perpendicular lines have a certain relationship, just like 2 parallel lines have a certain relationship between their slopes. Parallel lines have the same slope. If I want to write the equation of a line parallel to this one, I'm going to use that exact same slope. Perpendicular lines have a special relationship where the slopes are opposite signs from each other and reciprocals of each other, 2 different kinds of changes. So if this one up here started with a slope of 2, the one that's perpendicular to it is going to be opposite sign and reciprocal. That's how I got that. If I have a line and I know its slope is -3/4. If I want a parallel line, I'm going to use exactly that same slope. If I want a perpendicular line, I have to find the slope that's opposite sign and reciprocal. Those would be the slopes of 2 lines that were perpendicular to each other. Okay? Does that make sense?
Yeah, yeah, that helps. I just obviously need a little bit more time on this.
So, from this starting one, I figured out what slope I need to use to make it perpendicular. That's what you need to be able to figure out. You need to understand that relationship, that perpendicular lines have those 2 changes from each other. So here I am then plugging it in. It turned out when I did that calculation, right, that the y-intercept just happened to be 0. So I could say y equals -1/2 x, right? The slope I'm going to use is the perpendicular one now, plus 0, which I probably wouldn't bother to write. There's the equation of that line. This one should turn out to be the same. Distribute the -1/2. Now, if I subtract the 3 from both sides, yeah, there, same equation. Well,
If I were to write this equation down as a formed question, would I word it, find the perpendicular line of this equation? Is that how that would be written in like word terms?
Yes, very close to that. Find the equation of a line that is perpendicular to this line and goes through the point, whatever. There's another one, okay? Find the equation of the line that is perpendicular to, all right? 6 words I didn't write up there. Find the equation of the line that is perpendicular to this line and goes through this point. So that's giving you a starting equation to work from, to compare to. And here's the point eventually you're going to use with one of those forms. Now, so here's another problem. I gave you that equation. Can you come up with the equation of the perpendicular line that goes through that point? Means you have to figure out what slope to use. And then once you have the slope, you can use this point and one of those 2 forms. if you're working on a problem that wanted you to come up with a parallel line, it would be worded almost identically, except it would say, find the equation of a line parallel to a given equation and through a certain point. It's likely, just the way this shows up in this section, it's probably the last couple of problems in 4.6 are just like this. Excuse me. I would hope by now you've figured out the slope you're going to use, okay? And then you're plugging things into one or the other of the molds. If you've come up with the wrong slope, you're going to get the wrong answer, of course. So, hoping that you're there already, I'm going to say, here's the slope I would be using. Opposite sign and reciprocal. That's the slope you should be using. If you didn't use that, didn't come up with that slope, let's figure out why. I tried to make up numbers that worked well together also. It shouldn't be too messy to multiply by that fraction, I hope. Excuse me. Are you ready for me to do it?
Just like one more minute. Not to get too off topic, but was the last one we were trying to find perpendicular or parallel? Because I think that's where I was getting confused with the problem. I think that's where I was having issues.
That's why I wrote perpendicular. I wrote perpendicular.
Okay, but I know this one is perpendicular, but the last one that we worked on where I was confused and you were having to aid me through that, was that also perpendicular?
Yes, that's why.
Okay, that's why I was confused. I was getting my P words mixed up. Thank you.
I have the slope I'm going to use. I have this point. I'm going to plug those numbers into the form. Make sure I pick the y value. Don't mix them up. You know, I always say this, you know, we're multiplying fraction times the whole number. If you want to make that whole number look like a fraction, go right ahead. All right, we're going to multiply here. Maybe you'll notice you can cancel some 5s. And if I subtract, that looks like I got a negative 13 for my y-intercept. Now I have the y-intercept, the b, and the slope that I calculated or figured out early on. So my final answer is going to plug in m and b and get y equals 8/5. Make sure you're using the perpendicular slope, not the original one. And that was the version I came up with. If I'm using this technique over here, again, start by plugging the values in. Y minus, and the y value was a 3, so minus a 3 equals, here's that slope, and x minus happened to be a 10 there. So you have to be given a point to work with, and you figure out what slope to use. Distribute 8/5 x, and again, this would be what, 8/5 times the negative 10, which is going to be what, negative 16. That was supposed to be like a side problem. I'll erase it so it doesn't look like I'm trying to squeeze something in. Add the 3, and same equation, huh? So that equation is a line that's perpendicular to the original line. Equation happens to go through that point. All right. Hopefully you know, all that work coming out, we have to get this negative 13. Got to figure out what's the intercept, or rearrange it and intercept just works itself out. Excuse me. All right. A certain vendor makes $50 plus 10 cents for each item he sells each day. Let's say each day, okay? Write the equation that describes his earnings. Usually more, in terms of how many, whatever he sells. A vendor makes 50, this was, I think it was out of a book, a hot dog problem. A vendor makes $50 plus 10 cents for each hot dog he sells each day, for each item he sells. So using that information, it happens to be kind of real specific, the right numbers. Write the equation that describes his daily earnings in terms of how many he sells. The in terms of, that usually means, oh, that's the thing that you're going to be calling your X or your N or whatever variable you decide to use. So it's earnings, like total equals. And now you're going to come up with an equation that somehow says, how much money does he make if X stands for how many he sells? What are we looking for? Just like abstractly, we need a slope and we need a point to use. And depending on, the information, you might get a slope value directly. How much per item? This problem, I told you a slope. How much he makes per item. If you can think of the way, part about one of those numbers to have that per in it, he makes this much per item. That's going to be the slope. The point, it might be like a y-intercept value. Got to kind of interpret, analyze the information. Or maybe it's more like, if he does this much, he makes this much. It might be out in the middle of the problem, you might say it, which means we'd have to use one of our recent techniques for solving using some other point. But this problem, I'm giving you that fixed amount the starting amount plus a slope, right? I don't know, it must work for somebody, I guess, but somehow he makes $50, even if he doesn't sell anything, right? He shows up for work and makes $50 a day. Yeah. But he gets 10 cents for each one he sells. So here's your fixed amount. If you recognize that kind of value in a problem, it's always this amount. That's your starting or your y-intercept value. So that fixed amount, that's always like your y-intercept. Plus, there's your variable, there's your slope. Okay, I'm trying to talk this through, but maybe you were there already because this one, maybe you're getting familiar with this idea. But the total amount he makes then, now the order doesn't matter so much. Like I mentioned a day or two ago, you know, that sometimes the B is first, the fixed amount, and then the variable amount. Right, we could just switch places. B plus MX instead of MX plus B, doesn't matter, doesn't really matter. But here, it'd be the equation trying to get out of that story. The total amount he earns is $50 plus 10 cents per item, per X, all right? 10 cents for each item he sells. A word problem like this might follow up with additional questions. Once you have the equation, it might ask you things like, well, what are the units of the slope? What are we comparing this per that, you know, or earnings per item? If you can say a phrase like that, and it's always your Y per X, you know, earnings per item, there's your slope units. And then often there's follow-up like numbers, like if he earned $200 that day, how many did he sell? I'm not going to try to squeeze that on the board here. But if he, because you've actually done this kind of problem in the previous chapter where we were solving an equation. If he earns $200, I'll write it in. How many did he sell? So you have to know that, oh, that's that total number. Plug in the total. Get out of the way, Steve. And now, you know, rearrange. Subtract the 50, divide by 0.10, and figure out how many hot dogs he must have sold. It's been a good day. I think that's a really big number. I just made it up, right? Way too many hot dogs. A follow-up question might go the other way around and say, if he sold 100 hot dogs, how much did he earn? He sold 100 hot dogs. That means that put in 100 for X. If he sold 100 hot dogs. So interpreting the follow-up questions, are they giving me an X value to plug into my equation, or are they giving me a Y value to plug into my equation, and then I have to solve for the other one. I'm going to try to present several examples of word problem shapes here, okay? All right, here's one. A new copier, copy machine. Cost $1,750 and loses $180 in value, depreciation, you know, each year. Write the equation that describes its value based on years since its purchase. Businesses get to do this kind of thing with their equipment, you know, like write it off for tax purposes or something. Well, it's 5 years old means it's only worth this much in terms of what I have to pay taxes on or something. Depreciation. Now, only one O, sorry, I wrote loses. Loses, that's one of those kind of like choose and choose it. That's one of those common errors, I think. Loses. This is very similar in terms of the information to the last problem, but it's losing value. So that means something about what you have to put in your equation. Okay. Do you recognize I gave you a starting amount? You know, what's this thing worth when I bought it? And do you recognize that I gave you a slope, a rate of change? How much value is it? I'm kind of giving away the answer, right? Value per year or loss per year. There's the units of your slope, right? How much it's going down per year. So its value, all right, does it make sense? There was its starting value minus is what this one's all about. The slope is negative, right? It's going down. It's losing value. So it's losing $180 per year. The year based on, again, I didn't use that word terms, but this equation is based on, oh, here's my variable, years since its purchase. There's my variable, based on that variable number. I'm losing $180 per year from the starting value, $17.50. So there's my equation that describes the value of that printer. I already kind of talked, yes?
I'm a bit confused on why we're adding the 1750. If I were to do it on my own, I would think to subtract it since it's like decreased.
Yeah, this one almost makes a little more sense to have written it in that B plus MX. I'm going to do that over here, okay? Here, if I start from this, like in year 0, when I first bought it, it's worth that total amount. That's how much it started. You know, if I graph this, this would be going downhill, right? From a starting value. When I first bought it, it was worth this much, and now it's going down every year. Minus the 180x. I'm squeezing it in there. Sorry, getting messy. All right.
I guess that makes sense since the 180, that would be known as like the slope, right?
That is the slope, yes. The rate of change is minus 180 per year, definitely. So yeah, here's the B plus MX instead of
yeah, that helped a lot. Thank you.
Yeah, you know, I knew that as soon as I wrote that. It's like, okay, this one would have been better the other way. Oh well, sorry. And follow-up questions, right? Well, what would be its value in 5 years? What would be its value in 5 years? You're looking for the value, years, 5 years. Years are the X value, so you put in a 5, right? What would be its value in 5 years? So 5 times the 180, you're subtracting that. You know, it would have lost some value. Another question for this kind, especially the ones that go downhill, right? When is it not worth anything anymore? When can you totally take it off your, whatever they call that, capital equipment list? When is its value 0? All right. Here's this problem. It was worth this much when I bought it, and eventually, you know, it's not worth anything anymore. When? Years. When? I'm looking for the X's. When is it 0? Oh, I put in my 0. And now I have to solve for the number of years it takes to lose all of its value. Something like that. Okay. So purposely did one where, he earns, goes up and up and up, but I gave you a y-intercept. Here, this one's going down and down, but I still gave you the y-intercept, a starting value or a fixed amount to begin with. Pardon me. All right. And here goes. Here's one I pulled out of an old book I used to use. You're reading your history homework, and you have 35 pages to read. You still have 35 pages to read. After 10 minutes, and I'm going to look at my numbers so the problem maybe works out nice, and 5 pages left after working for 50 minutes. There's the information that the problem would present, and then you get that sentence, write the equation that describes how many pages you have left to read based on how long you have been reading. How many pages based on the number of minutes you've been reading. Okay, so pages based on the number of minutes. Pages per minute, well, there's my units. Pages per minute. Now, what's different about this one? I didn't tell you a slope, and I didn't tell you a y-intercept. I got 4 numbers in there. These are.
Is this going to be like the y1 or y2 minus y1?
You're going to have to do the slope yourself. These are 2 points, right? When I have, and in fact, this is helpful, right? I'm looking for basically how many pages per minute. That means pages is my y, right? So after 10 minutes, I have 35, and after 50 minutes, I'm down to 5. So you have to interpret that, and you have to give a little thought to, is it minutes per page or pages per minute? Sometimes it could work either way, so sorry about that. But you end up having to build 2 ordered pairs, 2 points yourself. This is one of those, they're just out in the middle there. I don't know the slope. I don't know the y-intercept. That's what you want to try to get out of that story, the application there. And so now you've got to start from scratch and calculate a slope. All right. And then once you've got the slope calculated, then we're going to have to use one of these techniques. Choose either point, right? Use the slope you found and one of the points to come up with the equation. Maybe do the solve for b if you like that technique, or plug it into the point slope method. We'll see how far we get. I'm not going to run out of time. 35, right? The y2 minus the y1. So started at 35 pages, ended up with only 5. Okay. But then that means I did 10 minus 50, right? Make sure you start from the same point.
So wait, isn't 5 y2?
It doesn't matter. It doesn't matter which one's which.
Okay. Because either way, we're going to end up with negative because you put the 10. Okay, I see.
If you switch them, then the negative would be on top and yeah.
Yeah, I see. Thank you.
Okay. So what is that? That's 30 over negative 40. A negative 3/4. Negative, kind of almost saying that I'm getting through three-fourths of a page per minute, right? The amount left to read is going down 3/4 of a page per minute. But there's a slope to use now. That's what all that was, right? Notice I reduced my fraction to make your life easy, huh? And sometimes even in problems like this, a decimal slope is not wrong. It could be, especially if you talk about money or something like that, maybe your slope makes more sense as a decimal value. But now I've got a slope and I'd have to plug it into one of those forms. Choose whichever point to work with that you want. It doesn't matter. You'll get the same y-intercept eventually. Right? Okay. If you want, we can come back and finish that up as an example of doing that again. My primary point in presenting these applications was to try to recognize and pull out the right kind of information, understand what it is you have to work with and what you have to do. We can do more of that on Monday, okay? More applications, a little bit of everything on Monday. If you look at that concept list I posted in the forum a few days ago, you might just, it's one of those, can I do that? Can I do that? Can I do that? The review problems, as always, are good things for you to look at. Hopefully you noticed, because of my absence, I bumped the test to Tuesday. I think that really works kind of better for you anyway. Do your best to get your homework done. Monday, we'll come back and review, warm up on Monday, and test on Tuesday. Hope that's not a problem for anybody. Okay, well, I am out of time today. I'll just leave this here. Try not to smudge it up too much over the weekend, and we'll come back and see if you want to do more on that one in particular, but I have a couple more examples. Okay, so I have to let you go, or I've got to go, and as always, send me your questions if you get stuck on something. So I'll see you Monday. Okay? All right. Bye.
Thank you.
Mm-hmm.